that it was significantly reviewed for security either. So that particular, it's certainly true that review matters, but that is little to do with the licensing. Finally, there's the argument about I can sue a vendor if it's insecure and inadequate. My experience is, frankly, that's not a very good argument. I don't know what things are like here in this country. I will say in the United States, most licenses simply forbid bringing suits. And frankly, you wanted software and a problem solved. You didn't want a lawsuit. So this really doesn't wash. It doesn't work. All right, so let's move on here. Let's talk a little bit more about security. How can I either make sure that the software I'm acquiring, that's FLOSS, is secure, or conversely, if I'm developing it, what must I do to make sure that the FLOSS is secure? Okay? There's basically three preconditions, and I'm talking about unintentional vulnerabilities. These are mistakes that lead to vulnerabilities. I'll talk in a moment about malicious ones. But these are, right now I'm talking about the unintentional vulnerabilities. First of all, the developers and reviewers need security knowledge. It's far more important to have knowledge than what license mechanism you're using for this point. Okay, what you want is to make sure the developers, now if there are some knowledges that do not know as much, that's fine. Find a way to educate them. And there's actually quite a bit of available literature on the internet that tells people how to do development in a secure way. Second point, and indeed oftentimes I will say in a community-based open source development model, oftentimes the more experienced developers help basically train those who are less experienced to explain to them, this is what you do, this is what you don't do, and so on. Second, people actually have to review the code. This tends to be less likely if it's niche, a rarely used program, there are few developers, a rare computer language. And although this may not look like it's not really FLOSS, there are still some programs out there which claim to be open source, but in fact are not at all. They don't even have an open source software license. And so a lot of the mechanisms that work for a FLOSS development don't apply to them because in fact they're not open source in the first place. More contributors tends to yield more review. So it's often helpful to figure out, is it truly community development? Is this just one person developing it? Or are there a large number of different people from different nationalities, different organizations working together? The latter tends to, of course, be far less risky because you're having a lot of people review it. And evidence does suggest that this really happens, and I'll point a little bit to that. Finally, certainly having knowledge is valuable. Reviewing and looking for problems is helpful. But you must make sure the problems that you find are fixed. It is, we are all humans. We all make mistakes. What we need to make sure of is that those mistakes are corrected, preferably before it is released to end users. So it's far better to fix it before development. But if a mistake does somehow slip out, need to make sure that it is deployed out to those users. So make sure that they have a process for releasing new versions to people who are using it if there's a security problem. Now, I did mention, what about examining FLOSS? Is FLOSS code ever examined? This was actually an argument 20 years ago. The argument was, well, okay, it's true that if a lot of people reviewed code, it would be better, but why would it, surely that would never happen. And of course, the answer is, well, yes, it does, but you need to look at your specific case. Most major FLOSS projects have specific code review processes. Typically has to go through several people to make sure that the code is acceptable and does not appear to have any vulnerabilities. I've listed 2 examples here. There are separate disseminated review groups which simply look for vulnerabilities and software other people write. Again, they tend to review the programs that are more important, that have wider use. There are a lot of static analysis tool vendors which test and demonstrate their programs by analyzing open source software. I've listed 2, but in fact there's a number of them. And there's many independent people who just look for vulnerabilities. Okay. So if you're evaluating FLOSS, you can use that as evidence. So first of all, try to identify what your security requirements are. If they're radically different than what the software is trying to accomplish, it's not likely that it will accomplish what you need, at least not without some changes. And then look for evidence at the FLOSS project website for those 3 points. Do they seem to know what they're doing? Do they seem to look for problems? Do they seem to fix them? These are all common sense things, but nevertheless, that's what you need to do. Look at the user and admin guides. Do they discuss how to make and keep the program secure? Is there a process for reporting security vulnerabilities? Are there cryptographic signatures, digital signatures for a current release to make sure you have the correct version and not something else? Do they discuss on the development mailing lists or whatever they use to discuss things, do they discuss security issues and work to make it secure? Is there an active community that's actively reviewing and trying to improve it? And of course, use other information sources that are available. There's other places that track vulnerabilities in software. And if you're looking for in general information on how to evaluate pre-existing FLOSS software, you were on the bottom. By the way, my understanding is that all of these slides will be available to you. So if this is a little fast, by all means, you can get them later. All right. So I've talked, hopefully, to at least a basic extent, about unintentional vulnerabilities. Now let me switch over to malicious vulnerabilities. This is where someone wishes to intentionally insert a vulnerability into a program. Obviously, this is a bad thing. If you are the recipient of this software, you wish to have this not happen. This, of course, is a problem for both open source software and proprietary software, really, and really for all software that you develop in-house. That's still a potential issue as well. Let me point out this first bullet because it shows a misunderstanding. It's why I showed that typical model about how open source software is developed earlier. Some people think, well, anybody can modify FLOSS legally, including attackers, so that must mean that FLOSS software is automatically less secure. See, unfortunately, this reflects a misunderstanding of how malicious attackers work. Okay? It is true that it's legal to modify open source software, and it's typically not legal to modify proprietary software. Someone who's inserting malicious software is already doing something illegal. They're not interested, nor do they care whether or not it is legal to insert code into something or not. Okay? So the legal niceties are not protection, okay, against someone who is intentionally trying to insert malicious code in. Okay? So really, you can actually modify a proprietary program the same way. Just take the CD, modify some bits, send it out. You can do that with Windows and lots of other software too. Okay, grab a laptop, change some bytes on it. You can make it do all sorts of things that the original developer probably didn't intend. Okay, the trick is not whether or not you can make some changes in a program. The trick is whether or not you can get it into the supply chain of the user. And this means fundamentally we're interested in malicious attacks which somehow subvert or mislead the trusted developers or subvert the trusted repository, okay, or the distributors. Okay, those boxes I showed earlier, we're worried about attacks that can manage to get into the supply chain of the end user. And of course, it not only has to get into the supply chain, it has to be a situation where nobody notices that later, because if it's noticed later, it can be removed. Now, I will note briefly there are lots of different kinds of threat types. Distributed source aids protection. And fundamentally, this bottom bullet I think is important. Large community-based FLOSS projects tend to have many reviewers from many countries, and this is one of the defenses, an important defense. It makes attacks more difficult. Okay? So if you're an evaluator of already existing FLOSS, basically you need to consider your supplier the same way that you would proprietary software. Are you willing to trust this person or not, and how much? The risk is larger for smaller FLOSS projects because generally you're going to have less review. So is there any evidence that FLOSS can deal with malicious code? The answer is yes. There was an attack on the Linux kernel several years ago where someone tried to insert malicious code into the repository. And the code itself actually was pretty clever. I don't know how many of you know the C programming language, but it used a clever trick where it used a single equal sign instead of a double equal sign. This is the sort of change, it looked correct. If you didn't look carefully, the code looked actually perfectly reasonable, normal. But it was very carefully designed to look